This is video number 3 on complex numbers. This is going to deal with add, subtract, multiply, and divide, the basic computation that you can do with complex numbers. We'll start with adding and subtracting because those are the two easiest pieces. You treat complex numbers like you would treat like terms. In this example, on the upper left-hand corner, I noticed that I have a whole number 2 and a whole number 9. That's my real portion, and 2 plus 9 is 11. And I have the imaginary part, the 3i and the minus 5i. Put those together and you get negative or minus 2i. And that's it. That's really all there is to adding. And you're not going to be surprised that subtracting works the same way. Take the real portions and get negative 7. 3i minus negative 5i. Just be careful with minus negative, but that's no surprise there. So we get plus 8i, and that's it. So adding and subtracting works just like you would with like terms. Multiplying reminds me of that old FOIL technique where we use the firsts, the outers, the inners, and the lasts, or kind of like distributing both of the first terms into the second binomial. So here we go. 2 times, I'll kind of do this as we go. So 2 times 9 is 18. 2 times negative I is negative 2i. 3i times 9 is 27i. And the 3i times negative I is negative 3i squared, right? It works just like the x's, except the I has kind of a special value. So let's put all this together. I have an 18, I have a minus 2i, and a plus 27i. So I'm just going to go plus 25i. I think everybody can manage that. And the minus 3i squared, we're going to give it a little bit more attention, make it a little bit neater also. I want to remind you that I is the square root of negative 1. So if I is the square root of negative 1, and I would square both sides, then I squared equals negative 1. So this part, zoom way in here, so this part is really minus 3 times negative 1, which is going to ultimately be plus 3. And you can see that plus 3 and 18 are going to combine together into 21. So the actual answer here is 21 plus 25i. So you'll notice that you really don't ever have yourself a situation where I squared is left over in any sort of answer. So now we've added, subtracted, and multiplied. If we have to divide complex numbers, I made myself a little note here. To divide complex numbers, you want to do this thing called eliminate the I from the denominator. That's kind of how this works. When dealing with radicals a long time ago, it was called rationalizing the denominator. And you would do that with a conjugate. Because these are complex numbers, we're going to use what's called a complex conjugate, which is just take this value and put a plus in between because it currently has a minus. So instead of 2 minus I, we're going to multiply by 2 plus I. That's going to be its complex conjugate. And we'll do the same thing to the top. So in reality, all we're doing is multiplying by the value of 1 because 2 plus I over 2 plus I is just 1. So we're not changing this thing, but we're going to make it look different, and that's really all dividing is. So here we go. I'm going to use FOIL on the top. 2 times 2 is 4. 2 times I is 2i. 3i times 2 is 6i. We're going to combine those together in just a moment. And 3i times I is going to be 3i squared. We'll talk about that. On the bottom, we have 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is minus 2i. That's good. And negative I times positive I is negative I squared. So now all I need to do is kind of clean this up because it's currently kind of messy. I'm going to use the eraser tool here and combine my 2i and 3i. I won't use the eraser tool. I'll go ahead and show you that these things are going to create an 8i. And this piece is going to end up being 3 times this piece. What I'm looking at right here is going to be 3 times negative 1. So that's just going to end up being minus 3. So I have 4 plus 8i minus 3. So we're going to clean that up in just a moment. And that'll become 1 plus 8i. And on the bottom, our goal here was getting rid of I on the denominator. That's really what we're doing with division. The plus 2i and the minus 2i cancel out. So those are going to go away. I have a minus negative 1. So that's going to become plus 1. And 4 plus 1 equals 5. So we have ourselves a fraction. There's no more I in the denominator. I'm happy with that. I could rewrite this if I wanted to as like 0.2 plus 1.6i if I felt like dividing each of those terms by 5, or I could just leave them as the fraction. I would say either one of these is acceptable and appropriate. And that's it. That's how you add, subtract, multiply, and divide complex numbers.